Okay. Today, I'm going to present about our team's project, which is the heart rate sensor and smartwatch blueprint. This is our team members. First of all, I sincerely thank Dr. Dung Huân Linh for her invaluable guidance and support throughout this project. Her expertise and insightful feedbacks were crucial in shaping the direction and depth of this report. My heartfelt thanks also go to my group for their collaborations and dedications. I am also thankful for the organization board of Technical Day for providing the resources and environment necessary for this work. Lastly, I extend my appreciation to my classmates for their continuous support and constructive discussions. Here are the roles of members in our project. As you can see, the five of us have each different roles, and we did fulfill it to create this project together. Let's go to our problem. In today's fast-paced world, stress and anxiety has long been a serious and alarming health issue. With a view to coping with such conditions, heart rate monitor is created to help users keep track of their cardiovascular data in real time. However, such gadgets often include unnecessarily overwhelming features that lack integrated ones that promote relaxation and reduce stress. Therefore, our aim is to create a wearable heart rate monitor which is capable of suggesting soothing, relaxing soundtracks with suitable interplays of tone and frequency based on our personal biometric feedbacks and heart rate. After coming up with this project, our team did a market research. As you can see, this is an Apple Watch SE, second gen. It's the most purchased heart rate monitor watch in the past month on Amazon. Its price is about $173.88. Its features includes fitness and sleep trackers, crash detection, heart rate monitor, retina display, and swim proof. Its disadvantage is that it is too overpriced, not many people can afford it. It has several unnecessary functions which can potentially make users feel overwhelmed and struggle to get accustomed to. Then, we did a research on the Fitbit Inspire 3, which is the most positively reviewed heart rate monitor watch on Amazon. Its price is about $96.99. Its features include stretch management, workout intensity, and sleep tracking. Its disadvantage is that it has a relatively small display screen and it cannot be turned off manually, which can potentially damage the battery in the long run. Here's our smartwatch 3D design. Here's the top view design, the bottom view design, and the side view design, which has the control button and the speaker. Our products have a heart rate sensor which primarily operates based on the principle of measuring changes in blood flow in the blood vessels beneath the skin, typically at the wrist or the finger. One of the most common technology used in heart rate sensor is the optical heart rate sensing and (PPG) uh, photoplasmography, where light is emitted onto the skin and the reflected light is measured to determine the heart rate. First, optical heart rate sensors use LED light shine light onto the skin, then the blood cells and tissues beneath the skin absorb the light. When the heart pumps blood, the amount of blood in the blood vessel changes, leading to variations in the amount of absorbed light. An optical sensor measures the changes in the light reflected back to the skin. Each time the heart beats, the amount of blood in the vessel changes, which alter the reflected light intensities. Then, the sensor captures the reflected light signal and converts it into its waveform. These pulses are then processed by signal analysis algorithm to determine the heart rate, measured in beats per minute. Signal processing systems distinguish between heart rate pulses and other interference signals, such as body movement or ambient lights. When the heart rate, measured in beats per minute, is too high, which is above 100 at rest, or too low, which is below 60 at rest, A signal light will be activated and suggestions of soothing, relaxing songs will be displayed on the screen. Here is our functional diagram. As you can see, the heart rate sensor sends the heart rate to the microcontroller where it calculates and the heart rate. And the signal will be sent based on the thresholds, which is the 100 beats per minute and 60 beats per minute to the decision box to recommend music and it appears the heart rate on the screen. Our technical design details is to integrate the aforementioned heart rate sensor into a smartwatch. We would suggest replacing the Uno R3 board with the STM32WB wireless microcontroller, as it is more suitable for the size constraints of a smartwatch and include built-in uh, Bluetooth Low Energy. Yes. Additionally, for higher resolution and performance, it would be ideal to replace the LCD1602 with an TFT LCD for better performance. For the case, we would use the plastic or titanium, and for the strap, we would use silicone or leather. Here's our testing process. As you can see, we put a fingertip upon the heart rate sensor. The sensor then captures this reflected light signal and convert it into a waveform of the heart rate. These processes are processed by aforementioned signal analysis algorithm to determine the heart rate. Uh, This is one of our failed results. As you can see, the screen doesn't display any heart rate data. It's because the heart rate sensor doesn't work. Uh, It has coding errors and connection cable between the heart rate sensor and the circuit is loose. But we did have a successful attempts like the first one that you just watched. It successfully read 7 and 76 beats per minute and its discrepancy due to user variations like the user's age, weight, and their fitness level. In conclusions, we utilize Arduino IDE to develop algorithm to determine the heart rate, and an additional one to trigger the signal light whenever the recorded heart rate is too low or too high. Moreover, to compensate for a lack of knowledge, resources, and time to develop a program capable of making smart music recommendations based on the user heart rate data and build a fully functional smartwatch, we decided to use AutoCAD to design a two-dimensional blueprint of the smartwatch to help the reader visualize and product easier and more vividly. Here is our references, and thank you for listening.